So welcome to this tutorial about large dataset visualization in Avizo. So this is my goals and my agenda actually, is to show you different scenarios and different strategies according to the hardware of your workstation. We're going to speak mainly about visualization of large data and to make movies, and at the end we're going to use some expert settings solve some more complicated situation. So which are the scenarios that you got? Usually, let's say, or the data is small, so usually you don't have any issue with that, with the default settings. For small, I mean the data fits in RAM and in GPU. Still, for this case, you may have to look at your default preferences. Large data set means for me data that still fits in RAM but not in GPU. This is pretty common. And finally we go for more advanced stuff with data that doesn't fit in RAM and in GPU. So then you have basically three possible strategy. One is you just do nothing. Okay, so you load the data, visualize, you let the default, and that's it. This may be okay for the small data set. Another one, you load everything in RAM because you can, but then you go to tweak your preferences because otherwise you see artifacts. And finally, the last one, for the most complex case, you do an offline conversion of your data into a proprietary file format we have for large data, and you tweak settings according to your data set. So let's see. So first obvious question is, how do I find the property, the hardware configuration I have, if you don't know. I have created here a table so you can read it with the techniques, how to do it. For RAM, actually the most easiest would be to go on top of system memory here on your toolbar, and you wait a while, you will get a pop-up with the information about your memory, available, use, total, etc. So indeed this column is a little bit useless, I would say, in my table. For the GPU it's slightly more tricky. You on Windows and probably on Linux as well, you can install Tech Power Up GPU Z, for example. There are many freeware that report the memory and the consumption of the GPU in real time. On Linux you also have a command line you can use, and on Macintosh you can just go to the About This Mac menu. So that's it. So now we suppose we know everything about the machine. In my case I have a 32 gig of RAM and 4 gig of GPU. So we're going to look at a watch, a micro CT scan of a watch. This is kindly provided by Werth Messtechnik. So sorry for my German pronunciation. So okay, so this data set, how big is it? You see it's about 1000 by 2000 by 2000 roughly, 16-bit, meaning 8 gig. So it fits in my RAM, but not in my GPU. It's a good candidate. So we have to see how to work with the default settings, and then what happens if I modify the settings. So where are the settings actually? They are here. You have seen, I click on Edit, Preferences, and then I go to the LDA tab, and you get here the main memory amount, meaning RAM. So by default I got 3 gig roughly, and video memory amount for volume rendering 500 megabytes, a little bit small, conservative, because my dataset is 8 gig. So we're going to see what happens with this default. Okay. So I expect to see some artifact actually, because I have only devoted half gig of GPU memory to visualize 8 gig. Yeah, so what happens, I start to, my goal is to make a video in which I look at the watch, then I move some cutting plane to look inside, etc., moving the camera around. So I try to mimic a little bit my video just quickly, and I immediately start to see that I have some artifact, especially if I zoom in and out. That's the most obvious way to reproduce the issue. Why? It's quite simple to explain. Avizo try to give you the best quality with the memory you're allowed to use on the specific viewpoint you have. So if you zoom in, it's going to concentrate the best quality on the zoom in. If you zoom out, then you will see for a while that Avizo has to adapt. So again, I want to cut my data to see inside. I have 2 clipping plane, so I do exactly the same. Then I will have an animation view, an animation script to do that with the animation editor. But at the moment I just do it manually, just to pre-validate in a way and see what's going on. So yeah, so I'm going to zoom in a little bit. So far, yeah, I start to see actually some artifact. Typically you have to look not in the center of the screen but on the side. If you zoom in very quickly in out somewhere, you may even see the problem in the center, because during the movement of the camera, by default we don't load anything to keep the camera movement very fluid. So by default we load only when you stop. So of course, if you zoom in and out or you rotate very quickly to a different viewpoint, you will see artifacts. So how to solve? In this case, increase the default basically. So like it's 8 gig, I give 3.5 in GPU and 10 in RAM. So now I should have enough memory for dedicated to visualization to avoid artifacts. Okay, so again I'm going to kind of mimic my animation for my video. Zoom in and out a little bit. Okay, this seems okay. Yeah, so you have to play with the viewpoint changes, or yeah, interacting with your data, like cutting, and see if you have suddenly some artifacts. Okay. Yeah, so I think we can skip a little bit this part, but basically I'm going to zoom in and you will see no artifact. You still see a flickering between the moving and the steady visual, and this is done on purpose to give you a better animation movement. So when you move the camera, the quality is a little bit degraded on purpose to have a faster frame per second camera movement. But then when you stop, the quality is correct. So let's move on. Yeah, so this is the video. So what I did, I create my videos with the 2 configuration, with low memory and high memory in the preferences. I recorded on disk, and now I'm going to play them with VLC using a nice feature of VLC. You can actually play 2 videos synchronized between them. You can pause, stop, move the window, so you get 2 windows synchronized with the 2 videos. It's pretty neat. So yeah, so I go up to the point in which the artifacts will be visible. Here it's not yet. Yeah, you have some actually here. Sorry. So then here you have another one. Yeah. See, it's put in evidence in the video. So yeah, as expected, with the 2 different configurations, you have artifacts, especially when the camera moves around, zoom in, zoom out, or the viewpoint change. because the data that was out of the video, out of the view, it's loaded at lower resolution, and the area that is in the view is higher resolution. Of course, if you have a lot of memory, this is less evident. Okay. Yeah. So now we go to another example. This is what I call a huge data set. You see, it's like 2400 by 2400 by 8000 roughly, 8-bit. So it's a battery. This is being kindly provided by Paul Shering's group and at UCL, and the acquisition is done with the Thermo Scientific Heliscan micro-CT. So yeah, it's a regular battery. So it's pretty big for my machine. So it's 45 gig roughly. So I don't have enough memory to load, and I don't have, of course, enough GPU. So what's the solution proposed by Avizo? We give you what it's called an octree solution. So the idea is that you take your input data that is about 45 gig and you pre-process it to create an octree with multiple resolution. So how this is built? The input data is split into small cubes that we call tiles. Typically they are 128 by 128 by 128 voxels. But you can change this size when you do the conversion. And so you split your entire volume in these small bricks, tiles, and then you build another bricked tiled volume up here that is lower resolution. Basically every 8 tile you create 1 tile of the same number of voxels, but the voxels are twice bigger. Okay, so you decrease the quality, but you keep the same number of voxels in every tile, and you continue to go up. Maybe you will get, I don't know, 8 resolutions like that. So you do this only once offline, so it's from disk to disk, and of course the output file will be slightly bigger than the input because you have all the resolution, but typically we compress the data during this process. So at the end you get a file that is smaller than the input. So another things I provide with the tutorial here, it's an Excel file that lets you compute exactly how much memory do you need, and it's interesting because it lets you understand a bit more about LDA. So in the Excel file you enter the information here on top left, how many voxel you have, what's the tile size, what the number of bytes per voxel, and you get kind of by magic here the size of your data and the size of your octree. So meaning you need 44 gig to keep the raw data and 53 gig to have all the resolutions. How this is computed, we can look quickly at the formula in Excel. The idea is that I use ceiling to divide this resolution and E by the tile size, and J by the tile size, and K by tile size. So I get 19 by 19 by 65 tiles. And then it's trivial, you multiply them and you multiply by the bytes per tile, and you end up having the memory you need at every resolution. And of course you need to do the sum of them to know how to reach a given resolution, because the loading is done progressively from low resolution to higher resolution. Meaning if I want to load the full resolution, I need to load first the lowest one, because you give a progressive rendering visual to the end user. Okay, so you will understand better this when you will get the Excel file. So how do I do the conversion? Simple: file, convert to large data. You get a new module and you specify the input. So for example, you have an Avizo file. It could be a list of stack of teeth or whatever. But okay, to make it simple in this tutorial, I use in Avizo file as input. You specify your output and how do you want to proceed, what is the tile size, do you want to compress, etc. So then you start the process. It's going to take a while because you need to convert 45 gig. Of course, I cut it in this tutorial, and you get an LDA file that you can load, and you can start to visualize. As usual, I would say, like in the same way you visualize stuff that is in memory. So what is going to happen for real? So I try to explain you a little bit how the LDA engine works. Okay. So remember, you have 45 gig on disk, actually 53 probably because you have all the resolution. And when you move around your visualization like slices, the engine will keep up, will continue to load dynamically on demand the data you need to visualize what you want. For this video, this specific one, I choose very low memory, like maybe 5 gig or less. So the idea is that you can see how the LDA react to the movement of camera, to the changes. Like I remove the slices, now all memory is devoted to volume rendering. And the volume rendering is not so big. And now I increase a bit more with the ROI box for volume rendering. So still I'm in full resolution here because I have black, the black box are the full resolution one, okay? And the yellow are the lower resolution. So now I choose a much bigger area of interest. Well, I have not enough RAM in my preferences to see this area. So the only solution would be to go in the preferences and increase the memory dedicated to the volume rendering to be able to see this. I think you get the point. This is the engine, how the engine works behind. So if you understand this, then you understand how to set up the parameters of the preferences. In my video, I am going to zoom in and like this and do a camera movement from the top of the batteries to the bottom. Very challenging because you see at the same time something near, something far. This is the typical case in which you see artifacts, right? Because the engine usually gives you high resolution image in front and low resolution in the back. So yeah, let's see. What we can do is, in this case, we use a module called HX LDA expert settings. You see, you type it in the console in TCL, create HX LDA expert settings. You get a new module here that will keep basically all the settings specific to this project. And this is advanced, meaning you have a little bit more control than in the preferences panel. So, but you can compare. It's almost the same. You have similar input things, but you will see a little bit more. So let's close this and go to this one. So what are all these parameters? It's a bit complicated to explain all of them, but let's say one very useful: data front outline, visual feedback. You can see what is really in the RAM with this. So the black tiles, remember, are the full resolution, and the texture front outline is the GPU memory. Okay, so you can debug in a way what's going on behind. Number of loading thread. Well, the data is on disk, very large. We load it in parallel with separate threads, not in the main thread, and you can control the number of threads. Loading policy, meaning when can I load data, when the engine can load data. By default is when there is no interaction, meaning when the camera is stopped, there is no movement around, but you can force LDA to constantly load or to stop loading completely. Fixed resolution, you can force the engine to load a specific resolution. We will see this. It could be useful sometimes, meaning instead of having this dynamic loading depending on the viewpoint, etc., I fixed my resolution to the half, for example. If the data is really too big, probably I have no other option. And this is explained. So even if the module is a little bit hidden because it's not in the menus, if you activate it through TCL console, then you can get the help. Okay. So let's move on. So we are going to see an animation. So I created with the animation editor this video. Basically, we cut the battery with the clipping playing, and then we are going to zoom in to see. Maybe it's not a very useful video, but it's nice to check if my quality settings are good or not, because you constantly have something near the camera, something far the camera. So that's usually, and this movement is very fast. So I want to be sure that my quality of volume render is always nice. Okay. So how can I ensure this? So I go back to 0. The idea is that, yeah. So I also control a little bit my quality. So I increase the sampling quality. This is going to make the volume render more beautiful in a way. Yeah, so we can see already that I don't have enough memory to hold the volume rendering, so I have to increase it, probably, right? So I can, of course, see the slices in full resolution, but the volume render you can see from its yellow tiles, so it's not in full resolution. So there is no choice here. If you want to have a constant, stable volume rendering visualized, it's better that you force the half resolution. And so then during the video, it's going to be smooth. And you can stop the LDM loading because the data is in memory, and I can also remove my view cooling, my viewpoint refiner, meaning I don't care about the view camera position. I want this quality kind of fixed, okay? And then I can move around my camera, and everything will be steady at this resolution. It's a choice. You may choose other, since you have the LDA expert settings, you can choose other strategies, but this is usually okay. So this is the video result. So I decided to have, you can see that you don't see visually any change in quality anytime because I fixed my resolution to the half for the volume rendering, and the slices stay at the full resolution, and so that's okay as a solution. Of course, you may try other way, like yeah, we will see in the next scenario. So this is another scenario. I have, it's the same data, but I want to do a different video. I want to move the slice constantly, and I want to be sure this is always full quality. So how can I do that? The trick here is to force the engine to constantly load the data, because I'm animating a slice. If I don't explicitly say that to the LDM, it's going not to do it. Okay. Another trick is use ROI box for volume rendering to focus on a small area. This is going to help the engine. So the engine will know that you don't care about the other area that is empty. So it's not going to load it, and you're going to spare memory a lot. So use the ROI box for volume rendering every time you have volume rendering to visualize only the part you need. And you will spare a lot of memory like that. Because the volume render is the most expensive one. In principle, to have full quality volume rendering, you need to bring the full quality in GPU. So, yeah. So I use a module from the extra to do the rotating slice. And I can debug. Yeah, this is very interesting. I stopped the video. You can notice here that the resolution here is not full resolution because I have here black tiles and here I don't. Why is that? Because of viewpoint refinement. So actually the same here on bottom. So the engine is preferring to give me high quality here and reduce the quality here. And probably is also giving some high quality to the volume rendering, okay? And I don't want to do that, actually. I want to have the full quality on the slices and maybe less quality on the volume. So I'm going to disable the viewpoint refinement. Yeah. Yeah, so this is going to help me to have less artifacting resolution on the slice. I'm going to increase the number of threads that loads data, and I'm going to force always in loading. This is okay because it's a video. So maybe if I do this yeah, so I also set up my memory to be as much as I can. So I have 2 spare gig. Let's load it. You see, my memory now is going to 94. Yeah, you have to prefetch as much as you can. Yeah, that's another important trick. And last one, you have to tweak. Yeah, this is another interesting parameter that many people ignore. When the memory is not enough, you can tell to the engine if you prefer to give more priority to slices or to volume rendering. So if you put it on the left, slice rendering is going to be get more memory, and volume rendering is going to get a little bit less. And this is nice for my case. This is what I want. I want the slice to be full high quality. Volume rendering, I don't care much. It's a little bit hidden. So, and of course I have my animation director to move the slice for the video. So let's see the final result of my video. Here you are. It's a rotating slice, and you don't see any loss of quality here. The volume render is probably rendered at lower quality, but it's not visible. So you have to be smart in a way. With advanced LDA expert settings, it's fine. So conclusion, small data, you probably don't do anything. You just load it in memory and that's it. Medium data, you have to carefully look at the preferences to increase the memory dedicated to visualization. Otherwise, you may see, even if it fits in RAM, yeah, you have to do that. And large data, well, you have to convert it to an LDA. You have no choice, and tune the LDA, and in some cases even go to expert settings. Yeah. Indeed, you can also use this technique for medium data. This is going to let you spare maybe some memory if you need it for computation. So this is the end of this tutorial. I hope you like it.